groove in the nacelle mainframe casting. Several studs are inserted to locate the ring as it is lowered into the groove. The ring is lifted and carefully lowered into position. The remaining studs are inserted and run down. Spacers are added. Then nuts are installed and checked with a gauge to be sure that enough threads are exposed for tensioning. An index mark is added to verify rotation of the nut during the tensioning process. In order to apply the loads evenly, bolt tensioning requires 3 people to set the tensions and 1 hydraulic operator. The tensioners are screwed down on the studs, then hydraulic pressure is applied to stretch them. Notice the puller moving up as pressure builds and how the nuts can easily be tightened. Next, hydraulic pressure is released and the process is repeated before moving to the next stud. Once all bolts are tensioned, a black index mark is added. Yaw motors is transmitted to the yaw ring through a reduction gearbox which provides both speed reduction and torque multiplication. This yaw drive uses a planetary gearbox, with the motor mounted vertically at the top. Planetary gearboxes are often used on commercial wind turbines because they offer high reduction ratios from a small, lightweight package and are able to transmit high torque to the yaw ring. These gearboxes are modular, meaning that several stages of reduction may be stacked to give the required output. This drawing shows a multi-stage gearbox. Notice that the gears in each stage get larger as power moves from the motor at the top to the output shaft at the bottom. This is because the gears must bear the increased torque loading. There are large bearings that support the output shaft for the same reason, and the output gear itself is very large. The gearbox is called planetary because the gears revolve around a central gear, the way that planets circle the sun. Here we can see how a planetary reduction stage fits into the gearbox. Notice the reduction effect. The sun gear rotates approximately 6 turns for each rotation of the planet gear housing. This is a 6:1 gear ratio. If this were the only reduction stage, and the motor runs at 600 RPM, the output shaft will turn at 100 RPM. Torque is also increased by a factor of 6 at the output gear. Reduction ratios for large wind turbines may be as high as 2,000 to 1.